Imagine this for a moment. You're lying beneath a sky so clear that the Milky Way looks like a river of light, flowing silently from one horizon to the other. Each star feels close enough to touch, and yet each one is impossibly far away. Between them lies the quiet, dark, the gentle hum of the universe stretching endlessly beyond what your eyes can see. Hey guys, tonight we're not just looking up at the stars we're leaving home, at least in our imagination. We're going to drift out beyond our galaxy, the Milky Way, and see what it truly looks like from afar. How big is it, really? How small compared to the giants of the cosmos? And what does that say about us, the tiny minds who dare to measure infinity? So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. It helps others find their way here too, one sleepy soul at a time. You can even tell me in the comments where you're listening from and what time it is there. I always love seeing how far our little constellation of listeners reaches. Now, if you're ready, let's begin. The story of our galaxy begins in silence. Not the silence of absence, but the silence of creation itself. Roughly 13.5 billion years ago, long before there were stars or planets or anything that could be called light, there was only the faint afterglow of the Big Bang. Imagine the universe then, a mist of hydrogen and helium, thin as breath, cooling and drifting through an expanding void. Slowly, gravity began to gather that gas into filaments, long invisible threads that wove the first great structures of the cosmos. Within those threads, knots formed dense pockets, where gas pooled, warmed, and eventually ignited. Those first fires were the earliest stars, and from their ashes, entire galaxies began to take shape. Our own Milky Way was one of them, or rather, a collection of smaller, primitive galaxies that collided and merged over billions of years. Each collision was both violent and creative, scattering dust and gas that would one day form new stars, new systems, and new worlds. In the vast stillness of cosmic time, what we call our galaxy was slowly sculpted by gravity's patient hand. You can imagine it like a great whirlpool forming in a cosmic ocean. Clouds of gas spiraling inward, drawn together by invisible tides until they flattened into a glowing disk. Within that disk, hundreds of billions of stars began to circle a common center, tracing paths so slow that a single orbit could take hundreds of millions of years. Somewhere in one of those spirals, far from the crowded core, a small yellow star was born. Around it, dust gathered into planets. And on one of those planets, much later, something remarkable happened. Consciousness appeared, eyes opened, minds began to wonder. It's strange, isn't it? Out of all the galaxies in the universe, 200 billion, maybe more, we live in this one, a single spiral of light, adrift in darkness. And somehow, we found a way to ask what it really looks like. But how do you measure something you can never step outside of? Astronomers face that very problem. We can't leave the Milky Way to photograph it from above. All we have are the faint patterns of light and dust, the movements of stars, and the radio whispers that echo through space. From those clues, scientists have spent generations piecing together a map, a portrait of home, drawn from within. They've learned that our galaxy is about 100,000 light-years wide. That means, if you could travel at the speed of light, the fastest anything can move, it would take you 100,000 years just to cross from one side to the other. And even then, you'd still be surrounded by stars, by nebulae, by the thin mist of interstellar gas that stretches between them. The Milky Way is vast, but it's not empty. Every point of darkness holds dust and memory, the remnants of stars that lived and died long before the Earth existed. Each speck of starlight you see tonight is part of an enormous family, bound together by gravity, moving in slow unison through the void. If you were to drift far enough away, hundreds of thousands of light years above the galactic plane, and look back, you'd see it glowing like a pale spiral shell. Its arms curl gracefully outward, dotted with pink nebulae where new stars are born. The center burns brighter, dense with ancient suns, surrounded by a halo of invisible matter that holds it all together. From that distance, the Milky Way would look delicate, almost fragile against the black. But within that fragile disk are hundreds of billions of stars, and around them, perhaps trillions of planets. Some may be worlds of ice, others of flame, and maybe, somewhere, another world that wonders about us. And yet, as large as it is, our galaxy isn't the largest, not even close. There are galaxies so immense they could swallow the Milky Way hundreds of times over. Galaxies whose halos stretch for millions of light years, whose centers shine with quasars bright enough to outshine entire universes of stars. Compared to them, we are small, a single swirl of light in a boundless sea. But that's the quiet beauty of it, isn't it? To know our place, to see ourselves not as the center, but as part of something grand and ongoing. As you listen, let your mind drift outward. Picture yourself leaving the solar system, passing through the thin clouds of dust and rock that mark its edge. The sun fades behind you into a pinprick of gold. Stars begin to cluster, then thin again as you rise above the galactic plane. Below you, the Milky Way spreads out a soft, glowing river of silver and shadow. You realize then that home isn't small at all. It's infinite in its own way, not because of its size, but because of the countless stories it holds. Every star is a possibility, every orbit, a memory of creation still unfolding. Perhaps the point isn't to measure how small we are, but to remember how rare it is to even ask the question, to be aware, to look up, and to feel wonder that's something no scale can define. So tonight, as the galaxy turns slowly above you, remember that you're moving with it, orbiting through space, at hundreds of kilometers per second, part of a dance that began before there was time to name it. Close your eyes if you'd like. Let that thought settle in. You are inside the galaxy that dwarfs you, and yet, somehow, you're big enough to hold it in your mind. Out there in the night, every star seems perfectly placed, as though the sky itself were a great, still painting. But astronomers know that what looks fixed is always moving. Stars drift, light travels, and our sense of scale, the way we imagine distance, is constantly tricked by the quiet of the dark. When you look up at the Milky Way, you're really seeing into time. The light from the nearest stars left them years ago. The light from the farthest, thousands of years. Every shimmer is an echo of what once was, not what is now. And yet, from those echoes, we have learned to measure the unmeasurable. How do you take the size of a galaxy that you cannot step outside of? It begins with parallax, the gentle wobble of a nearby star against the background of others as Earth moves around the Sunday. Astronomers noticed this centuries ago. By measuring that shift, they could calculate how far a star was from us. The distances were enormous, but still within our cosmic neighborhood. Beyond that, the wobble disappears. The stars become too far, the angles too small to see. So they reached for brighter candles. Certain kinds of stars, Cepheid variables, pulse with a rhythm directly linked to their true brightness. By comparing how bright they appear to how bright they should be, astronomers can tell how far away they are. It's a little like hearing a familiar voice in a fog and guessing how distant the person is by how faint they sound. With that method, we began to trace the shape of our own galaxy. We found that the Milky Way isn't a perfect disk, but a gentle spiral, its arms winding around a dense, glowing center. We learned that our sun sits about 26,000 light-years from that center, halfway out on one of the smaller arms called Orion. It's a quiet suburb of the galaxy, far from the crowded heart where stars are born in violent bursts. Then came the radio telescopes. When optical light was blocked by dust, radio waves passed through easily, mapping the hidden structure of the Milky Way. The 21-centimeter signal of hydrogen, that faint whisper emitted by atoms themselves, became our compass. From it, scientists charted our galaxy's rotation, its spirals, and the faint haze of gas stretching far beyond what we can see. And later still, with space telescopes and infrared observatories, we began to see the stars themselves, peering through the dusty clouds that once hid our galactic heart. Each improvement in vision was like lifting another veil, revealing that the Milky Way was not a single flat disk, but layered a thin luminous plane, surrounded by a halo of ancient stars and invisible matter. Invisible matter, dark matter, is one of the strangest clues of all. When astronomers measured how fast stars move around the galactic center, they discovered something impossible. The outer stars orbit far too quickly. According to the gravity of what we can see, those stars should fly off into space, but they don't. Something unseen holds them in place, a vast halo of mass that doesn't shine or absorb light. Dark matter makes up most of our galaxy's weight, shaping its very size, defining a boundary we can never quite see. So, when we say the Milky Way is 100,000 light-years across, that's only the visible part, the part made of stars and gas. The dark halo extends more than 10 times farther, a silent sphere of gravity, reaching out nearly 1,000,000 light-years in every direction. We live inside that invisible ocean, held by forces we can feel but never touch. Even with all these measurements, the truth remains elusive, because to measure the Milky Way is also to measure motion, the slow swirl of billions of suns around an unseen axis. Our galaxy rotates once every 230 million years. In all of human history, we have barely moved a single degree in that grand orbit. To us, the stars seem still, but they are flowing through space like leaves carried on a slow cosmic river. And so, astronomers build models, equations, and maps. They compare the brightness of distant stars, the drift of clouds, the gravitational tug on nearby galaxies. Each new observation sharpens the picture, a little more a puzzle of light pieced together by patience. It's humbling to think that every number, every estimate, comes from photons that began their journey long before the first humans ever looked up. Some of the light we use to measure our galaxy left its source when the Earth itself was still forming. We are measuring the present using the language of the past. Yet, in this strange way, the universe allows us to know it. Even trapped within our galactic island, we've learned to chart its shores. We can say, with quiet confidence, that we orbit a supermassive black hole about 4 million times the mass of the Sun, that our spiral arms cradle hundreds of billions of stars, and that our entire disk drifts through the local group of galaxies at roughly 400 kilometers per second. Still, when you step outside at night, none of that math is visible. What you see is something older, simpler, and infinitely more human. The same sky our ancestors once watched, with no instruments but wonder. They too tried to measure it, not with rulers or light years, but with myth. To them, the Milky Way was the milk spilled by a goddess, or the path of spirits crossing into eternity. Maybe that's the most honest way to understand measurement, not as a cold calculation, but as a kind of reverence. Because when we measure the galaxy, what we're really doing is reaching out gently to touch the edges of our own imagination. So, as you listen now, let yourself drift between those two ways of knowing the scientific and the sacred. Feel the quiet awe of knowing that somewhere, light from distant suns is still traveling toward us, bringing with it the story of who we are and where we belong. Close your eyes. Picture the Milky Way turning, not as a diagram, but as a living thing, a vast glowing wheel, its arms dusted with stars. Inside that slow rotation is you, measuring, dreaming, and breathing, a tiny pulse within a cosmic heartbeat. And maybe, just maybe, that's what it means to measure the unmeasurable, to realize that knowing is less about numbers and more about wonder that never ends. If you could drift far enough away from our galaxy, far beyond the faintest edge of its light, you would finally see what no human eye has ever truly seen: the Milky Way in full. From that distance, it would hang in the darkness like a vast, luminous whirlpool, a spiral of silver-blue stars turning ever so slowly in the black sea of space. It wouldn't look crowded, not like the night sky you know. It would look soft, a glowing disk, about 100,000 light-years across, thin and bright in the center, tapering to darkness at the edges. Around it would shimmer faint halos of gas and ancient stars, and beyond that, the invisible sphere of dark matter stretching so far that it could swallow entire clusters of galaxies inside its gravitational reach. From that distance, our galaxy seems calm and still, like a painting. But up close, it's alive, full of motion, full of soundless storms. Every star you've ever seen, and billions you haven't, is circling the galactic center on its own path. Some move fast, slicing through the spiral arms in orbits that last hundreds of millions of years. Others move slower, trailing behind like quiet companions. And through it all, the galaxy itself turns, a vast wheel of light, dust, and gravity. To understand the Milky Way's shape, astronomers had to imagine it from within. It's like trying to draw the outline of a forest while standing in the middle of the trees. You can't see the whole, only hints how the stars cluster, how gas clouds curve, how radio waves drift through the void. Piece by piece, the map emerges, and what it reveals is something beautiful. Our home is a barred spiral galaxy, one of the most elegant forms the universe ever created. In the heart of the Milky Way lies a glowing bar of stars, a dense band that cuts across the center like a luminous bridge. From the ends of that bar, 4 great spiral arms unfurl, curling outward in graceful arcs. The Perseus arm, the Scutum Centaurus arm, the Sagittarius arm, and our own small Orion arm, the one we call home. Between these arms, vast dark lanes of dust wind through space, hiding thousands of stars from view, and giving the Milky Way its mottled, cloud-like appearance when seen from Earth. The spiral shape isn't fixed. It's more like a wave of density that moves through the disk regions where gas and stars bunch up, then spread apart again. Stars are constantly being born in the dense ridges of these arms, lighting up the darkness with new suns, nebulae, and planetary systems. Over time, the wave moves on, and what was once a star nursery becomes an aging population of fading light. In this way, the galaxy breathes, expanding and contracting through epochs longer than all of recorded human history. At the center of it all sits something mysterious: Sagittarius A*, a supermassive black hole, nearly 4 million times the mass of the Sunday. It doesn't shine, yet its presence shapes everything. Stars whip around it in dizzying orbits, some completing a full circle in just a few decades. Astronomers have watched them move, bright points tracing invisible ellipses around an unseen center. That's how we know it's there, a silent gravity well, holding the entire galaxy together. If you could fall toward it, you would cross vast layers of light, first through the inner bulge, where old red stars cluster densely together, then through swirling clouds of dust glowing with infrared heat, until at last you reach the edge of the black hole's event horizon. Time itself would stretch there. Seconds would slow, and from the outside, you would seem to freeze forever, a whisper of light captured at the edge of forever. But our journey tonight isn't to fall in, it's to rise above. Imagine now that you're floating high above the galactic plane, far enough that the entire disk of the Milky Way lies beneath you like a soft spiral shell. From here, you can see its shape, the thinness of it, the faint bulge in the middle, the delicate curvature of its arms. The whole galaxy is only about 1,000 light-years thick, like a coin compared to its width. If the Milky Way were the size of a dinner plate, the thickness of that plate would be less than a single strand of hair. And yet, inside that slender disk is everything we know. Billions of suns, trillions of worlds, nebulae, comets, dust, radio waves, magnetic fields, an orchestra of invisible forces, all playing in harmony. It is thin, yes, but it is not fragile. It's held together by gravity, by motion, by balance, the same physics that binds planets to stars and keeps moons circling worlds. Sometimes, late at night, when the Milky Way stretches across the sky like a river of milk, it's easy to forget what we're actually looking at. Those faint clouds aren't clouds at all, they're our galaxy seen from within. We are inside one of the arms, looking edge-on through its stars, seeing billions of suns overlapping like grains of sand in a beam of light. What appears smooth to our eyes is, in truth, infinitely detailed, a tapestry woven from light years. And somewhere in that tapestry, the sun drifts quietly. It takes about 230 million years to make one full orbit around the galactic center. That means, since the day the dinosaurs first walked the Earth, our solar system has only completed one revolution. We are still newcomers in this slow, cosmic dance. Every generation of life on Earth, every civilization, every dream, every breath happens within just a fraction of a single galactic year. The Milky Way itself is old, around 13.6 billion years. It has seen stars born and die, galaxies collide, and planets melt and freeze again. It has survived explosions that could have wiped out entire clusters of worlds. And yet, it endures, turning silently through the dark. The shape we see now, the graceful spiral arms, the glowing core, is just one moment in its long evolution. Over the next billions of years, it will keep changing. The arms will twist tighter, the stars will drift farther apart, and one day, the Milky Way will merge with its neighbor, the Andromeda Galaxy. When that happens, the elegant spiral you see now will vanish, replaced by a vast, elliptical glow, a single giant galaxy born from two. But that's a story for later. For now, the Milky Way is still what it has been for ages, a spiral of peace and persistence, turning slowly in a sea of infinity. So tonight, as you listen, imagine you're rising higher and higher, the stars beneath you thinning into dust, the disk of our galaxy stretching to fill your vision. Feel the silence of space pressing gently around you. There's no wind here, no sound, just the slow hum of starlight and the steady pulse of time. You are looking at home, not a city, not a planet, not even a star, but the great spiral of being that made all of them possible. In its shape lies every story you've ever known. In its turning, the quiet rhythm of eternity. And somewhere, in one small arm of that glowing wheel, a single world turns, and someone looks up just like you and wonders what it all means. If you step outside on a moonless night, far from cities and noise, you might see 3,000 stars with the naked eye. 3,000, it feels infinite when you're standing there, doesn't it? The sheer number overwhelms the senses. And yet, those few thousand visible points are only a whisper of the Milky Way's true abundance. Our galaxy holds something closer to 400 billion stars, maybe more, maybe less. No one knows the exact number, because the stars themselves keep secrets even light cannot fully reveal. To count them, astronomers don't use fingers or eyes. They use mathematics, telescopes, and patience. They begin by studying a small patch of the sky, a window so narrow you could cover it with your fingertip at arm's length. In that single patch, they measure the density of stars, the light they emit, and the distance between them. Then, carefully, they multiply those findings across the whole galactic disk. Like counting grains of sand in a single handful and imagining the entire beach, they estimate how many stars must fill the rest. Even with the best technology, the result is always an approximation. Some stars hide behind dust clouds so thick they block every wavelength of visible light. Others are faint red dwarfs, too small and dim for our instruments to detect. There are regions in the galactic center so crowded and turbulent that even radio telescopes struggle to distinguish one star from another. So, the count changes 400 billion, 300 billion, maybe 500 billion, and that's just in the Milky Way alone. And every one of those stars is different. Some are enormous blue giants, shining 10,000 times brighter than our sun, burning fast and dying young. Others are tiny embers, brown dwarfs that never ignited fully, glowing faintly with leftover heat from their birth. Between those extremes lie countless varieties: orange stars, white dwarfs, pulsars that spin like cosmic lighthouses, and even double or triple star systems where 2 or 3 suns orbit each other in a slow celestial waltz. When you look at the Milky Way's bright band stretching across the sky, you're really looking through the dense heart of one of its spiral arms. The light you see is the combined glow of millions of distant suns, blending together into a single misty shimmer. If you could zoom in, the blur would separate into individual points, a forest of light so dense that night itself would seem to disappear. But even that view would show only a sliver. The Milky Way is thick with layers upon layers of stellar populations. The oldest stars dwell in the central bulge, ancient red suns that formed when the galaxy was still young and chaotic. Farther out, along the spiral arms, younger generations of stars light up vast nurseries of gas and dust. Between those regions, dark clouds weave through space like shadows, the raw material for future stars waiting to be born. A star begins with gravity and dust. In the cold depths of a nebula, atoms of hydrogen gather slowly, pulled together by their own weight. As they compress, pressure builds, heat rises, and deep inside the forming core, something miraculous happens. Nuclear fusion ignites. Hydrogen becomes helium, and light bursts forth. A new sun is born. Some shine for billions of years, steady and calm, while others burn themselves out in a few million, exploding into supernovae so bright they can outshine the entire galaxy for a brief instant. Every explosion seeds the galaxy with heavier elements: carbon, oxygen, iron, the building blocks of planets, oceans, and life. When those atoms drift together again and form new stars, they carry within them the ashes of older generations. You, sitting here, are made from that same cosmic dust. The iron in your blood, the calcium in your bones, all of it forged in the hearts of ancient stars that died long before Earth existed. So, when you look up at the Milky Way and think about numbers, billions, trillions, light years, ages, remember that counting stars isn't just science, it's genealogy. You're tracing your lineage back to the first fires that ever burned. Every number we assign, 100 billion, 400 billion, is a whisper of ancestry, a cosmic family tree. And yet, astronomers keep counting. They can't help it. Every new telescope reveals more than the last faint companions orbiting larger stars, clusters hidden behind veils of dust, streams of stars flowing like rivers through the galactic halo. Some discoveries redefine what we thought we knew. A single deep image can add millions of unseen suns to the tally. The more we look, the more infinite the sky becomes. Think of the Hubble Deep Field, a photograph of what seemed an empty patch of sky. In that emptiness, there were 10,000 galaxies. Now imagine a similar field taken inside our own galaxy. Every tiny patch of darkness would hide thousands of stars. Each of those stars could have planets, and on some of those planets, perhaps, something is looking back, counting too. When the numbers grow so large, the mind gives up trying to comprehend them. 400 billion. It's a number too vast to feel. So, let's bring it closer. Imagine standing in a field at night, holding a single handful of sand. Each grain is a star. The entire beach, every grain from every shore on Earth, represents the stars in our galaxy. The scale stops being mathematical. It becomes meditative. You begin to feel small, yes, but also connected, part of the same cosmic continuum that holds everything together. And still, even that vast number is not the end. Beyond the Milky Way, there are hundreds of billions of other galaxies, each with their own billions of stars. Multiply that again, and you get a universe with more suns than there are atoms of air in every breath you take tonight. Somewhere, light from those distant stars is already on its way to you, traveling across millions of years, crossing cosmic dust and silence, just to arrive at this moment. So, maybe we don't really need to count the stars. Maybe it's enough to feel them, to know they're out there, countless and steady, each one a tiny spark in the same great darkness. Because when you look up, you're not just seeing stars, you're seeing the history of everything that ever was, and everything that might still be. Let that thought rest gently in your mind as the night deepens. Every flicker above you is a heartbeat in the galaxy's long, slow rhythm. You are watching time itself unfold, one star at a time. And somewhere out there, another being might be counting. Two not to measure, but to remember. Close your eyes now. The numbers fade. What remains is light, uncounted, unending, quietly alive. Beyond the shining arms of the Milky Way, beyond the clouds of stars and the glowing dust, lies something we cannot see, a presence without light. A vast and ghostly halo that holds everything together. Astronomers call it dark matter, but the name is almost poetic because it isn't just dark, it's invisible, silent, and utterly mysterious. For a long time, no one knew it was there. Early astronomers assumed that what we could see, the stars, the gas, the nebulae, was all that existed. But as we learned to measure how galaxies move, the numbers stopped adding up. Stars at the edges of galaxies were spinning too fast. According to the laws of gravity, they should have flown away into space, scattered like sparks from a fire. And yet, they didn't. Something unseen was holding them in orbit, like a hand we couldn't see but could feel. That invisible hand is what we now call dark matter, a hidden mass that outweighs all the visible stars combined. It doesn't shine, doesn't absorb light, doesn't react with ordinary matter in any way we can detect. It simply is, and it surrounds every galaxy like a vast, transparent sphere, a halo of gravity binding the stars to their cosmic home. If you could somehow see it, the Milky Way would look very different. The glowing spiral we know would sit at the heart of an enormous shadowed bubble, stretching nearly 1 million light-years in every direction. Most of that space would appear empty, but it isn't. It's filled with this unseen matter, perhaps made of exotic particles that slip through everything, even our own bodies, without leaving a trace. Astronomers discovered its existence not by sight, but by inference, by following gravity's fingerprints. When a galaxy spins, its outer stars should move slower than the inner ones, just as the outer edge of a spinning record moves faster in distance but slower in turns. But when astronomers mapped the Milky Way's rotation curve, they found that the outer stars were not slowing down at all. They were moving, as if the galaxy were much heavier than it appeared. Something massive was hidden beyond the stars, pulling on them. Other galaxies showed the same pattern. Wherever we looked, the same invisible structure appeared. Clusters of galaxies, bound by gravity far too strong for their visible mass alone, all surrounded by halos of the unseen. Even the bending of light gravitational lensing revealed the same ghostly pattern. The universe, it turned out, was filled with more darkness than light. In fact, everything we can see, every star, every planet, every cloud of gas, makes up less than 5% of the total universe. The rest is invisible, about 27% dark matter, and 68% something even stranger, dark energy, a force that pushes the universe apart. The visible cosmos is just the foam on top of an invisible ocean. But let's stay close to home for a moment, to the halo that surrounds our own galaxy. Imagine it as a sphere of silence. Inside it, billions of stars orbit like fireflies, caught in an invisible glass globe. Every planet, every comet, every cloud of hydrogen drifts within this vast, unseen web. Even the light from the galactic core, the bright heart of Sagittarius A, times bends slightly as it passes through. Some scientists believe this halo may be made of particles called WIMPs, weakly interacting massive particles. Others think it might be Alcyoneus, or something stranger, still forms of matter that existed since the earliest moments of the Big Bang and never mixed with ordinary atoms. Despite decades of experiments deep underground and in orbit, no one has yet captured a single particle. The dark halo remains an unbroken mystery, patient and perfect in its silence. If we could see it, it would transform how we understand the Milky Way. The galaxy's luminous disk, the part with all the stars and nebulae, would seem like a small bright coin floating at the center of a vast glass sphere. This sphere, this invisible architecture, defines the true shape of our galaxy. Without it, the Milky Way's spiral would fall apart. The stars would drift away, scattering into the void. The dark halo is the glue that holds our cosmic home together, even though it hides from every telescope we've built. There's something humbling in that thought. The majority of what keeps our world intact, what keeps our sun circling safely, what keeps the Earth where it is, comes from something we cannot see, cannot touch, cannot measure directly. We are surrounded, sustained, and balanced by a presence that remains unseen. Maybe that's a kind of quiet metaphor for life itself. So much of what shapes us, memory, emotion, the invisible gravity of love and loss, can't be measured, yet it defines everything we are. In the same way, the galaxy's dark halo holds together the stars not with light, but with its invisible pull. What is unseen doesn't mean it's unreal. As the Milky Way drifts through space, its dark halo moves with it, brushing softly against the halos of neighboring galaxies. Sometimes they overlap. Gravity weaves invisible bridges between them, like faint filaments of glass connecting distant lights. These bridges form part of a grander structure, the cosmic web, the scaffolding on which all galaxies are strung. The Milky Way is not isolated. It hangs within this web, tethered by gravity to Andromeda, the Magellanic Clouds, and countless smaller companions. Together, they move as one great family through the dark. If you close your eyes now, you can imagine it. A sphere of invisible energy surrounding you, larger than any world, stretching farther than any dream. The stars you see are only the tiniest fraction of what truly exists. And yet, even without seeing it, you are inside it, held gently in place, carried through the universe by a halo of quiet power. So tonight, as the world around you falls silent, think of that halo, the one that holds our galaxy together, the one that has kept every sunrise possible for billions of years. Invisible, yes, but always there, always waiting. If you could shrink the Milky Way down to the size of a dinner plate, our sun would sit halfway between the center and the edge, a small golden speck, drifting along one of the spiral arms like a grain of dust caught in a swirl of light. That's where we live, not in the glowing heart, not on the bright rim, but in a quiet neighborhood called the Orion Arm, or sometimes the Orion Spur, a peaceful lane between two of the galaxy's great highways of stars. Here, far from the chaos of the core, space feels calm. The stars are scattered, not crowded. Radiation is lower. The pace of cosmic life slows. In this suburban corner of the Milky Way, our Sun has been circling the galaxy for more than 4 billion years, tracing an orbit so vast that it will take another 230 million years to complete a single revolution. Since Earth was born, we've made the journey around the galaxy only 20 times. Every night, when you look up, you're seeing our neighborhood from the inside. The band of light stretching across the sky, the Milky Way itself, is the view from our living room window, looking edge-on through billions of other stars that share our orbit. It's as if you were standing inside a great glowing disk and could see its rim stretching to infinity. Our solar system drifts about 26,000 light-years from the galactic center, a comfortable distance, far enough to avoid the dense radiation near the core, but close enough to feel the pull of the galaxy's gravity. We orbit that center at nearly 828,000 kilometers per hour, fast enough to cross the United States in less than a second. And yet, in the vastness of space, it feels like stillness. There's no wind, no resistance, just the slow, steady turning of everything. Around us are stars of every kind, massive blue giants that burn out in a few million years, gentle yellow suns like ours, and cool red dwarfs that will outlive all the others. Some are close enough that their light reaches us in a handful of years. Others are so far that their photons began their journey before humanity learned to speak. The Orion Arm itself is a narrow bridge, about 3,500 light-years wide and 10,000 light-years long. On one side lies the Perseus Arm, a grand spiral filled with brilliant star-forming regions. On the other, the Sagittarius Arm, a denser, older realm closer to the galactic center. Our little spur sits quietly in between, not too hot, not too crowded, a perfect balance. And maybe that's no coincidence. Some scientists think our location may be one of the reasons life had a chance to evolve here. Too close to the core, and radiation from supernovae and black holes would tear atmospheres apart. Too far out, and there might not be enough heavy elements to form rocky planets like Earth. But here, in this middle zone, the conditions were just right, a cosmic Goldilocks region on a galactic scale. In the quiet between the arms, our Sun orbits peacefully. Every 230 million years, it completes one galactic year. That means the last time our solar system was in this same spot, dinosaurs were just beginning to roam the Earth. The time before that, the first amphibians were leaving the seas. Every full circuit is an era of transformation. Continents drift, species rise and vanish, and the stars around us change. The night sky of the dinosaurs looked nothing like ours, and the sky of the future will look different again. Yet, there's a rhythm to it all. Our Sun bobs gently up and down as it travels around the galaxy, oscillating through the galactic plane like a ship riding slow waves. It takes about 30 million years to rise above the disk, another 30 to sink below, tracing a graceful, endless sine curve through the sea of stars. Each time it crosses the plane, it passes through regions thick with gas and dust, places where new stars are forming. Some scientists wonder if these crossings, every 60 million years or so, might even influence the Earth's history, stirring up comets in the outer solar system or shifting the cosmic environment in subtle ways. Still, through all this motion, the Sun remains steady, a patient traveler carrying its family of planets along for the ride. Earth, a small blue dot, orbits the Sun. The Sun orbits the galaxy. And so, we move in nested circles, like gears in an immense, silent clock. Each revolution takes eons, yet it never stops. Even as you breathe now, you're hurtling through space, following an ancient path carved long before life began. If you could watch the galaxy from above, you'd see our solar system tracing its way along the Orion Arm, a small spark moving through a field of light. Around it, the spiral arms twist and turn, alive with supernovae and glowing nebulae. Every now and then, the sun passes close to a star cluster or brushes through the edge of a gas cloud, changing the brightness of our night sky. But mostly, we drift through emptiness, a calm, dark ocean dotted with light. To know our place in that ocean is to feel something paradoxical, both small and vast at once. Small, because our entire history fits within a single breath of galactic time. Vast, because we are part of a structure so immense it defies imagination. A structure that has turned for billions of years and will continue long after we are gone. Sometimes, when astronomers simulate the galaxy's motion on supercomputers, they notice something poetic. The stars move like a flock of birds, each one following its own path, yet together forming patterns of motion, spirals of grace. The Milky Way isn't a static object. It's a living system, a choreography of billions, and we are one of its quiet dancers, carried along in step. You might think that being halfway out in a spiral arm makes us ordinary, but it's precisely that ordinariness that gives us perspective. From here, the light from the galactic core reaches us without blinding us. The stars around us are few enough that we can see beyond them to the distant galaxies scattered across the cosmos. If we were anywhere else closer in, or farther out, the sky might be too crowded or too empty to inspire wonder. But here, from this middle ground, the universe feels perfectly balanced between chaos and calm. So tonight, as you lie under the stars, remember where you are, not just on Earth, not just circling the sun, but halfway up one spiral arm of a galaxy that turns slowly in the dark. You are inside a cosmic garden, spinning with everything that ever was and ever will be. Every star above you is a neighbor, every beam of light a connection across impossible distance. Our place in the galaxy isn't the center, and it isn't the edge. It's something far more precious a place, to look both inward and outward, to feel the pull of belonging and the thrill of infinity. And as the Milky Way drifts on, quietly turning, so do we, small luminous travelers, perfectly placed between the heart and the horizon of home. For most of human history, we believed the Milky Way was the entire universe. We thought that the faint river of stars across the night sky contained everything that ever existed. Every sun, every planet, every dream. It was only in the last century that we realized the truth. Our galaxy is just one among billions, and among those billions, there are giants that make even the Milky Way look small, fragile, and young. When we gaze through telescopes, we see shapes that defy imagination, galaxies so vast they span millions of light years, their cores burning with countless suns. Some are quiet spirals like ours. Others are colossal ellipticals, smooth and golden, glowing like cosmic lanterns. A few are so large that if the Milky Way were the size of a coin, they would stretch across an entire football field. The largest of them all are often found in the hearts of galaxy clusters, those great gatherings of hundreds or thousands of galaxies bound together by gravity. In those dense regions, galaxies collide, merge, and grow, devouring their neighbors until only one massive elliptical remains. These ancient titans are called brightest cluster galaxies, and they are among the most powerful structures in the cosmos. One of the greatest we've found is IC 1101, located over 1 billion light-years away in the constellation Virgo. It's so large that if it replaced the Milky Way in our sky, its outer edges would reach beyond the Andromeda Galaxy. IC 1101 spans nearly 6 million light-years from end to end, 60 times the width of our own galaxy. Inside it, there may be 100 trillion stars, enough to give birth to countless worlds and still leave room for the dead light of ancient generations. But despite their scale, these galaxies are not always the most beautiful. Many of them are smooth, featureless ovals, lacking the graceful spirals and dark lanes of dust that make the Milky Way so striking. They are the ghosts of galaxies, the result of cosmic cannibalism, where smaller systems were swallowed over billions of years. Each one carries within it the remains of hundreds of other galaxies that once spun freely, now blended into one enormous whole. In their centers lie monsters, supermassive black holes, far larger than our own Sagittarius A*. The one inside IC 1101 is estimated to be more than 40 billion times the mass of the Sunday. To imagine it is almost impossible. Its gravity would swallow not just planets or stars, but entire solar systems at once. Around it swirls a glowing halo of hot gas, millions of degrees in temperature, emitting X-rays that stretch across light years. These giant galaxies are ancient, nearly as old as the universe itself. They were formed when the cosmos was still young, when matter was dense and collisions frequent. Over time, they became islands of light, surrounded by vast voids of darkness. From their outer edges, you could look out and see almost nothing, just the faintest shimmer of neighboring galaxies, scattered like sparks across the cold, black sea of intergalactic space. Compared to them, our Milky Way seems almost delicate, a spiral of starlight quietly turning on the outskirts of a small group of galaxies. But there's something poetic in that smallness. The giants burn bright, but often fade fast, their star-making fuel consumed long ago. The Milky Way, by contrast, is still young enough to create new stars, new worlds, new possibilities. We are not a dying flame, we are still mid-song. Astronomers have measured the Milky Way's mass at around 1 trillion times that of the Sun, which sounds immense until you realize some galaxies weigh 10 or 20 times more. Others, like the Phoenix A galaxy, are surrounded by enormous plumes of gas and light, stretching millions of light-years outward, dwarfing anything we can imagine. If our galaxy were a campfire, these would be blazing suns that never set. But perhaps what's most extraordinary is that these giants, for all their power, still obey the same cosmic rules. They spin, they shine, they age, and they die. Gravity shapes them the same way it shapes us, slowly, patiently, always pulling, never relenting. The laws that govern their hearts are the same laws that make your heart beat, that hold you to the earth as it turns beneath the stars. If you could stand on a planet, orbiting one of the distant suns, inside one of those giant galaxies, the night sky would be almost blinding. There would be no darkness at all, just light upon light, countless suns crowding the heavens until every inch glowed. The Milky Way, from that perspective, would be nothing more than a faint speck in the far-off void, a minor star cloud adrift in infinity. And yet, from our small corner of space, we look back at them and feel awe, not envy. Their enormity reminds us that we are part of something without limits. It tells us that there is no single scale that defines existence, that small things, too, can hold universes within. Our galaxy might be modest, but within it are the raw materials of consciousness, the atoms of thought, the capacity to wonder. No galaxy, no matter how large, can do that. As you listen now, let your mind drift outward, past our sun, past the spiral arms, past the halo of invisible matter. Imagine rising above the local group of galaxies, seeing Andromeda, Triangulum, and the Milky Way as tiny glowing coins floating together in the dark. Then, go farther still. The light grows thinner. The space between galaxies stretches wide and quiet. Ahead, the true giants begin to appear, soft, golden orbs glowing faintly in the distance, each one a cathedral of starlight, each one too vast for words. They turn slowly, silently, each in their own corner of eternity. And though they may dwarf us, they are not separate from us. We are made of the same dust, moved by the same gravity, shaped by the same fire. In their scale, we see our reflections smaller, yes, but no less miraculous. So perhaps the giants exist not to make us feel insignificant, but to teach us how enormous our own capacity for wonder really is. For what could be grander than to look into infinity and feel at home? If the Milky Way is a graceful spiral, delicate, balanced, full of motion, then the elliptical galaxies are its quiet opposites. They are the ancient giants of the cosmos, round, smooth, and luminous, like faded pearls floating in the blackness of intergalactic space. While spirals spin and sparkle, ellipticals glow steadily, a diffuse golden haze that stretches for millions of light years. They are not young galaxies. They are the galaxies of memory. An elliptical galaxy doesn't have the swirling arms or dark ribbons of dust that define spirals like ours. Instead, its stars are scattered in every direction, forming a roughly spherical shape with a dense, bright core at the center. Most of its stars are old, tens of billions of years old, born in the earliest ages of the universe. They shine faintly in the red and yellow spectrum, long past the blue brilliance of youth. These galaxies are not nurseries of creation. They are museums of starlight, where the fires have burned low but never gone out. Some are modest in size, small ovals only a few thousand light years across. Others are vast beyond comprehension, the colossal ellipticals that anchor entire clusters. One of them, Messier 87, sits at the heart of the Virgo cluster, a giant so massive that it dominates its surroundings like a sun among fireflies. If the Milky Way were placed next to it, we would look like a single spiral of dust beside a mountain of stars. Messier 87, or M87, is home to one of the largest black holes ever discovered. Its mass is nearly 6.5 billion times that of the Sun, so enormous that it bends light itself into a glowing ring. In 2019, the Event Horizon Telescope captured that shadow for the first time, a blurry, golden circle suspended in darkness. For a brief moment, humanity saw what had only been imagined, the edge of nothingness itself, glowing where space and time dissolve. Inside galaxies like M87, the story of the universe is written in silence. No new stars form in their depths. Their gas has long been used up or blown away by ancient supernovae and the fierce winds of black holes. What remains is the afterglow of creation, hundreds of billions of aging suns orbiting in slow, random motions. These galaxies no longer dance, they drift. Their light is soft, their boundaries hazy, fading gradually into the intergalactic dark. But they are not dead. Their cores still pulse with unseen energy. In many ellipticals, the central black hole feeds on a trickle of gas, releasing jets of plasma that stream outward for thousands of light years. These cosmic fountains glow in radio waves, painting the void with invisible arcs of power. If we could see them with our eyes, they would appear like glowing wings, stretching out from the heart of the galaxy, a quiet reminder that even in apparent stillness, there is motion. Astronomers believe these colossal ellipticals are born from collisions. When two or more spiral galaxies merge, their delicate arms are torn apart by gravity. The stars mix and mingle until their orbits become random, losing all sense of order. What's left is a great, featureless sphere, a fossil of chaos shaped by violence and time. Over billions of years, the collisions continue. Small galaxies are swallowed, large ones fuse, and the result grows heavier, smoother, older. Eventually, it becomes what we call a CD galaxy, a monster so vast that it contains the remnants of hundreds of smaller systems. Some of these giants, like NGC 4000, 889 inches, the Coma Cluster, or ESO, 146 to 5, stretch over 1 million light-years from end to end. Their stars number in the trillions. Their gravitational pull binds entire clusters together, shaping the space around them. If you were to stand on a planet orbiting one of their stars, if such a world could exist, the night sky would never be dark. It would blaze with countless suns in every direction, filling the heavens with eternal twilight. Compared to them, the Milky Way seems almost young, still forming stars, still building worlds, still restless. The ellipticals have moved beyond that stage. They are the elders of the cosmos, glowing softly in their long dusk. Their beauty lies not in movement or complexity, but in endurance. For 10 billion years, they have shone without pause, steady beacons of light in a universe that keeps expanding and cooling. And yet, even they are not eternal. Over unimaginable spans of time, their stars will burn out. White dwarfs will fade into black embers. The galaxies themselves will dim until only their central black holes remain, spinning slowly in the darkness. In the far future, long after the last spiral has lost its arms, these ancient ellipticals will be the final islands of light, the universe's last whispers before the deep sleep of entropy. It's strange to think that in a way, our own galaxy is destined to become one of them. When the Milky Way and the Andromeda galaxy collide billions of years from now, their spirals will merge and dissolve, leaving behind a smooth, golden sphere, a future elliptical. It will shine for trillions of years more, silent and serene, until even that light fades. But tonight, that ending is far away. For now, we can simply imagine them, the colossal ellipticals, floating quietly in the deep, their ancient light crossing millions of years to touch our eyes. They are not just structures of stars, they are time itself, condensed into form. They remind us that everything, galaxies, planets, people, moves through cycles of birth, growth, and rest. So as you drift towards sleep, picture them immense golden orbs suspended in black space, each one glowing softly with the memory of creation. They are the universe's oldest dreams, still shining, still waiting. And within their calm, perhaps, lies a lesson for us, that stillness can be beautiful, and that even the quietest light can last forever. If galaxies are islands of light, then clusters are their archipelagos, enormous gatherings of hundreds, sometimes thousands, of galaxies bound together by gravity. Each one is a miniature universe, complete with spirals, ellipticals, dwarfs, and halos of dark matter. From afar, a cluster looks like a cloud of fireflies frozen in mid-air, some blazing brightly, others dim and distant, all moving together through the slow current of cosmic time. The Milky Way, small though it may seem, belongs to such a family. We live inside the local group, a cluster of a few dozen galaxies stretched across 10 million light-years. The biggest members are our own Milky Way and the Andromeda galaxy, followed by the Triangulum galaxy and a scattering of faint dwarfs that orbit like quiet satellites. Together, they drift through space, connected by gravity's invisible threads, but the local group is only a tiny corner of something much greater. It lies on the edge of a vast, slowly rotating structure called the Virgo supercluster, home to thousands of galaxies. And even that supercluster is merely one filament in the even grander Laniakea, a colossal web of matter that spans 500 million light-years. In every direction, the universe forms this same pattern. Galaxies grouped into clusters, clusters woven into superclusters, superclusters linked by filaments, all separated by immense voids of nothingness. When we look at the night sky, we see individual stars, points of light in our own galaxy. But when astronomers look deeper, beyond the stars, with telescopes that peer into the ancient past, they see the large-scale structure of the cosmos, a lattice of glowing threads, each bead a cluster of galaxies, each thread an arm of the cosmic web. It's as if the universe itself were a vast living organism, its veins and nerves stretching across infinity. Inside a cluster, the scale of gravity is hard to imagine. Galaxies swirl around one another like bees around a hive. Though their dances take billions of years to complete, collisions are inevitable. When two galaxies meet, they do not smash together like solid objects. Instead, they pass through one another, their stars rarely colliding, their gas clouds merging, their shapes stretching into long tidal streams. Over time, those encounters transform elegant spirals into smooth ellipticals, feeding the growth of colossal central galaxies that dominate their clusters like monarchs in a court of light. The Coma Cluster, one of the nearest large clusters to us, lies about 320 million light-years away. It contains more than 1,000 galaxies, each one home to billions of stars. Through a telescope, it looks like a swarm of faint glows, some white, some yellow, some tinged with red, drifting together in a sea of darkness. Between them lies a faint haze called intragalactic medium, an ocean of hot gas heated to tens of millions of degrees, glowing softly in X-rays. That gas, more than the galaxies themselves, makes up most of the cluster's mass. It's a reminder that even here, between galaxies, the universe is not truly empty. Clusters are also held together by vast halos of dark matter, far outweighing the visible galaxies. Without that unseen glue, the clusters would fly apart. When astronomers measure how galaxies move within a cluster, they find that there must be far more mass than meets the eye, a pattern that repeats everywhere we look. The universe, it seems, hides most of its weight in shadow. From a cosmic perspective, clusters are like milestones in the universe's growth. In the beginning, right after the Big Bang, matter was spread almost evenly throughout space. Tiny fluctuations in density grew slowly under the pull of gravity, attracting more and more material until the first clusters began to form. Over billions of years, those small knots became the grand structures we see today, chains of galaxies, bound together by invisible threads of gravity and time. If you could drift through one of these clusters, you'd see galaxies glowing all around you like lanterns suspended in the dark. Some would be close enough that their halos overlap, merging into shimmering bridges of stars. Others would be distant ghosts, faint and unreachable. You might pass through regions where the gas itself shines faintly, bathing everything in an eerie golden light. And in the deepest reaches of that glowing fog, you might glimpse entire galaxies being born or destroyed. Yet, despite their enormity, clusters move too. They drift through space, drawn toward even greater gravitational centers. The entire Virgo cluster, and with it, the Milky Way, is slowly falling toward a mysterious region called the Great Attractor, a dense zone of space hidden behind the Milky Way's own plane of stars. We can't see it directly, but we can feel its pull, a reminder that even on the grandest scales, nothing stands still. To think of all this is to feel something between humility and wonder. Here we are, on a small planet, circling a small star in one spiral arm of one galaxy, a galaxy that itself is part of a cluster, part of a supercluster, part of a web that stretches across creation. Every night, when you look at the stars, you're looking not just outward, but inward, into the great pattern of which you are a living part. Our Milky Way may seem solitary, but it's never alone. It's bound by unseen ties to countless other galaxies, all swirling together in the same cosmic rhythm. Their light, traveling for millions of years, sometimes reaches us as faint smudges in a telescope's lens, whispers of kinship from across eternity. So the next time you feel small, remember this. You are part of a cluster too, one made not of galaxies, but of hearts and minds, all orbiting the same quiet curiosity that makes us look up at night. We are not alone, not in the sky, not in the soul. The universe itself is a cluster, and every being, every thought, every breath adds one more point of light to its ever-growing glow. Let that thought cradle you as the night deepens. Somewhere, far beyond our stars, 1,000 galaxies are turning together in silence, their light crossing millions of years just to find you here, listening. If you could step outside the universe and look back not from one galaxy or one cluster, but from some impossible vantage beyond space itself, you would not see a void scattered with lonely stars. You would see a pattern, a great, luminous web, stretching across unimaginable distances, connecting everything that has ever existed. This is the cosmic web, the vast architecture of the universe, an invisible lattice of dark matter and light that threads through the cosmos like veins through a living body. Every bright node is a cluster of galaxies, every glowing strand a filament where gravity has drawn matter together across billions of years. Between these filaments lie enormous voids, regions so empty they make the space between stars seem crowded. From that faraway view, the universe doesn't look random. It looks alive, pulsing with structure, symmetry, and flow. The same gravity that binds the Earth to the Sun has, over cosmic time, woven galaxies into filaments hundreds of millions of light years long. They cross and merge and stretch, forming a network so immense that light itself takes ages to travel its breadth. The idea of this web began as a theory. Astronomers noticed that galaxies weren't scattered evenly through space. They gathered into clusters and superclusters, leaving great gaps between them. Computer simulations in the late 20th century recreated this pattern, showing that after the Big Bang, slight ripples in the early universe's density caused matter to collapse into a web-like structure. The densest parts became clusters. The threads between them became filaments. The empty regions became the cosmic voids. Today, we can actually see that structure, not with the naked eye, but with telescopes that map galaxies across billions of light years. Projects like the Sloan Digital Sky Survey have charted the positions of millions of galaxies, revealing the cosmic web's filigree pattern in exquisite detail. It's as if the universe, in its vastness, were a single woven fabric, and every galaxy, including ours, were a tiny glowing bead on one of its threads. Our own local group, with the Milky Way and Andromeda at its heart, sits inside one such filament on the edge of the Laniakea supercluster, a sprawling domain containing more than 100,000 galaxies. The name Laniakea comes from the Hawaiian language. It means immeasurable heaven, and truly it is. It stretches 500 million light-years across, its farthest edges linked by faint gravitational currents that flow like rivers through the dark. Within these cosmic rivers, galaxies drift slowly, drawn toward regions of greater density. Over billions of years, they migrate along the filaments, merging, colliding, and reshaping themselves. The Milky Way and Andromeda, for instance, are both sliding along a gravitational slope that will eventually bring them together. From the highest perspective, it's all part of the same cosmic dance, the slow circulation of matter through the grand web. But what's perhaps most breathtaking is that this web doesn't just organize galaxies, it creates them. Inside the filaments, gas flows inward, funneled by dark matter's gravity. Where the streams intersect, galaxies form. Where they merge, clusters ignite. And where the threads grow thin, new ones are born. The web is not a static structure, it's a living process, always changing, always building. Even the voids, those vast, seemingly empty spaces between the threads, are not truly nothing. They contain faint whispers of hydrogen, thin as ghostly mist, stretching across light years. In those emptier regions, the cosmic microwave background still hums softly, the afterglow of the Big Bang echoing through eternity. The web connects all of it, light and dark, fullness and emptiness, creation and silence. Some scientists describe this structure as the skeleton of the universe, but the word skeleton feels too rigid for something so dynamic. It's more like a great neural network, the brain of the cosmos, firing and flickering with energy. The parallels are uncanny. Just as neurons in your brain connect through synapses, galaxies connect through filaments. The scales are unimaginably different, yet the patterns are strikingly similar. Perhaps, in some strange way, consciousness and cosmos are built from the same design, a web of connection, a pattern of flow. When we study the cosmic web, we're not just learning where galaxies are, we're learning how everything, even us, came to be where it is. Every atom in your body once belonged to a cloud of gas that moved through those filaments billions of years ago. The oxygen you breathe, the calcium in your bones, the iron in your blood, all of it followed those cosmic paths, drawn slowly into the Milky Way before the sun was born. The web is not just out there, it runs through you too. And though we call it dark, the web is full of light. Where its filaments intersect, clusters blaze with countless suns. Each tiny point of light you see in the night sky is part of one of those glowing intersections, a memory of the web shining through the dark. Even the blackness between stars, the space you think of as empty, is shaped by its threads. The universe's silence is not emptiness. It is the stillness between the strings of a great cosmic instrument. If you could float there between the galaxies, you might not see the web directly, but you could feel it. Gravity would tug faintly in every direction, an invisible tide linking you to everything else. And if you waited long enough, millions of years perhaps, you'd see galaxies sliding along those lines of force, slowly changing positions like beads on a necklace. Time, in the web, is fluid. Everything moves, yet nothing rushes. So tonight, as you breathe and listen, imagine yourself as part of that network, a single point of awareness, connected by invisible threads to every atom, every star, every galaxy. The same laws that shape the web shape you. The same gravity that pulls galaxies together keeps your feet on the ground. The same fabric that weaves clusters together also weaves your existence. The web of the cosmos isn't out there. It's here. It's within you, around you, and beyond you, endless, delicate, alive. And as you drift towards sleep, perhaps you can feel it, that soft, infinite connection that ties everything together, a gentle vibration humming beneath the silence of all things. When you look up at the night sky, it feels like the Milky Way stands alone, a shining island surrounded by emptiness. But if you could pull back far enough, you'd see that we're not alone at all. We are part of a small but lively neighborhood of galaxies, each moving, turning, and breathing in the same cosmic sea. Our closest neighbor, the Andromeda Galaxy, lies just 2.5 million light-years away. That sounds distant, but in galactic terms, it's next door. If the Milky Way were the size of a dinner plate, Andromeda would be another plate, just across the table, slowly sliding closer. Between them stretch countless streams of invisible matter, faint bridges of hydrogen gas and dark matter that link the two galaxies together. Andromeda, also called M31, is larger than our galaxy, home to perhaps 1 trillion stars. Seen through a telescope, it appears as a misty oval, faint and serene. Yet that faint smudge is an entire world of worlds, suns, planets, nebulae, black holes, and civilizations that might look back and wonder about us in return. The light you see from Andromeda tonight began its journey before the first humans ever walked the Earth. Every time you look at it, you're looking into the deep past. Andromeda and the Milky Way are bound by gravity. They're falling toward one another at about 110 kilometers per second. In 4 billion years, they'll meet. The collision won't be violent in the way we imagine. The stars are too far apart to actually crash. Instead, the two galaxies will merge in a slow, graceful dance, stretching, twisting, and reshaping into a single, enormous elliptical galaxy. When that happens, the night sky from Earth, if Earth still exists, will be breathtaking. Andromeda will grow larger and larger until it fills the heavens with rivers of light. And eventually, the two galaxies will become one. But Andromeda isn't our only companion. Scattered around the Milky Way are more than 50 smaller galaxies, most of them faint and easily overlooked. The most famous are the Large and Small Magellanic Clouds, two irregular galaxies visible from the southern hemisphere. To the naked eye, they look like small smudges of light-drifting islands of stars that orbit our galaxy like moons. For centuries, sailors in the southern oceans navigated by them, calling them Clouds of the Magellan. The Large Magellanic Cloud, or LMC, is about 160,000 light-years away and contains tens of billions of stars. It's a lively place, full of star-forming regions. One of them, the Tarantula Nebula, is the most active stellar nursery in our local universe, a glowing cauldron of gas where stars are born by the thousands. Nearby, the Small Magellanic Cloud, a little farther out, dances along its companion's orbit, the two galaxies tugging on each other like twins bound by an invisible thread. There are others, two tiny, faint galaxies with names like Sagittarius Dwarf, Fornax Dwarf, and Draco Dwarf. They are so dim that even large telescopes struggle to detect them. Some contain only a few million stars, others only a few 100,000. Yet they are as ancient as the Milky Way itself, fossils from the early universe, still circling quietly in our halo. Astronomers have found streams of stars stretching across our sky, remnants of these dwarfs torn apart by the Milky Way's gravity. Their fragments now orbit among us, their light becoming part of our own. In recent years, scientists have discovered even more of these hidden companions. Some were revealed through subtle patterns of motion among stars. Others were found by tracing faint ripples in the Milky Way's outer edges, echoes of past collisions. Our galaxy, it seems, has been devouring smaller neighbors for billions of years, growing larger and more complex with every meal. And in turn, Andromeda has been doing the same. If you could watch the local group in fast motion sped up over billions of years, it would look almost alive. The big galaxies drift toward each other, the small ones orbit and collide, and faint bridges of gas form and break, connecting them all. It's a cosmic ballet performed in slow motion, silent yet full of purpose. Even beyond our local group, the space around us teems with neighbors. There's the Triangulum Galaxy, M33, a delicate spiral smaller than ours, connected by a faint gravitational thread to both Andromeda and the Milky Way. There are tiny dwarf galaxies like Leo First and Leo II, wandering farther out, like lost siblings at the edge of the family. Together, all these galaxies form a single gravitational community, bound to one another not by proximity alone, but by history. Every one of them has influenced the Milky Way's evolution in some way. The Magellanic Clouds stir waves in our galactic disk, triggering new bursts of star formation. The Sagittarius Dwarf, currently being torn apart, leaves behind long ribbons of stars' cosmic graffiti painted across the sky. Even Andromeda's approach is shaping us, subtly altering our motion through space. We are not passive in this universe. We are part of a living network of neighbors whose fates are intertwined. And yet, how little we see of them with the naked eye. From Earth, the sky feels empty. Only Andromeda is visible as a faint blur to those who know where to look. The rest, billions of suns, billions of worlds, remain hidden, waiting for the patient gaze of telescopes to bring them into view. It's humbling to realize how much of our own neighborhood is invisible to us. Still, in the quiet hours of the night, when the air is clear and the world has fallen asleep, you can feel that presence, a gentle awareness that we're surrounded by other galaxies, each one carrying its own stories, its own destinies. Some are coming closer, others drifting away, but all of them are part of the same grand motion. You are not just part of the Milky Way. You are part of a local family of galaxies, sharing the same cosmic sky. And every time you look up, you're looking through their light, even if you can't see it. So tonight, as the stars shimmer overhead, imagine them out there, Andromeda, luminous and patient. The Magellanic Clouds, bright ghosts in the southern dark. Dozens of smaller galaxies circling in silence. A whole neighborhood turning slowly through the endless night. You might not see them, but they are there, and they are moving with us, always closer, always together, in a universe where even galaxies never drift alone. Every galaxy is in motion. Though the night sky seems still, every point of light above you, every star, every spiral, every distant shimmer is moving through space with silent precision. The Milky Way, too, is drifting. Our entire galaxy, with its hundreds of billions of stars and its invisible halo of dark matter, sails through the cosmic sea at nearly 2 million kilometers per hour. And on that same ocean, another traveler is heading our way. Her name is Andromeda, our sister, our mirror, our future. Right now, she lies 2.5 million light-years away, her light faint but visible as a pale oval in the night sky. Through a telescope, you can see her core, a soft, glowing center, surrounded by delicate arms, each one laced with starlight and dust. Her structure is almost identical to ours, a barred spiral with swirls of newborn stars and vast, dark rivers of interstellar gas. For now, she moves quietly against the backdrop of the universe. But her motion is not random. It is a long, slow fall straight toward us. Astronomers have measured her speed with extraordinary precision. Andromeda is approaching the Milky Way at about 110 kilometers per second, roughly the distance from one side of a city to the other every second. It's a gentle pace by cosmic standards, yet unstoppable. Gravity has bound the two of us together in an ancient, invisible embrace, and nothing will break that bond. In about 4 billion years, the Milky Way and Andromeda will collide. But the word collision is misleading. When galaxies meet, they don't crash like solid objects. They pass through one another, their stars separated by such immense distances that few will ever collide directly. Instead, their shapes distort and merge, drawn out by gravity into long, elegant streams of light. Gas clouds will slam together, triggering bursts of star formation that will light up the heavens. New suns will ignite. Nebulae will bloom like galaxies within galaxies. It will be chaos and creation, in equal measure the quiet violence of beauty. Imagine the view from Earth as that happens. Over the next billion years, Andromeda will grow brighter in our sky. First, she will appear as a small hazy patch, then larger, her spiral arms becoming visible to the naked eye. Eventually, she will fill the night from horizon to horizon, a glowing whirlpool so vast it will make the Milky Way itself seem small. For a time, the two galaxies will overlap, their stars mingling into a single cosmic tapestry. The sky will blaze with unfamiliar constellations, the heavens remade before our eyes. And then, the dance will begin. The first pass will tear at the outer arms of both galaxies, sending tidal streams of stars curling into space like ribbons. Gravity will twist the Milky Way's spiral into loops and arcs, while Andromeda's core will stretch into a brilliant bridge of light. Slowly, they'll swing apart again, only to fall together once more. Each approach will reshape them, pulling, stretching, blending, until finally, after several passes over a few billion years, the two will merge completely into one. The result will be something new, an enormous elliptical galaxy that astronomers already have a name for, Milky Way, the child of two spirals. It will shine twice as bright as either parent, a golden sphere of stars glowing softly in the quiet dark. Its central black holes, Sagittarius A times, and Andromeda's own massive twin, will spiral toward one another, radiating waves of gravitational energy until they merge into a single supermassive heart. By then, the Sun will have changed too. In about 5 billion years, it will swell into a red giant, its heat burning away the inner planets, perhaps even Earth itself. But if life still exists somewhere in the outer solar system or beyond it, the night sky will be the most extraordinary spectacle in the history of existence. The heavens will be alive with movement, galaxies flowing together, stars forming and dying in waves of fire. The universe will look both violent and serene destruction, giving birth to creation. It's worth remembering that collisions like this are not rare. They are the universe's way of recycling itself. Every large galaxy we see today, including the Milky Way, was built from smaller ones that collided and merged over billions of years. Our stars, our planets, even our atoms are the products of those earlier unions. The upcoming merger with Andromeda is simply the next chapter in that long story. It's not an ending, but a transformation. Astronomers have simulated the event in fine detail. They've traced the paths of billions of stars, watching how they weave together. In some simulations, the Sun survives, flung into a wide new orbit far from the galactic center. In others, it drifts through the glowing bridges of new stars, its night sky a river of fire. Whatever happens, the result will be quiet, slow, and magnificent. To a human eye, if one could exist to see it, the sky would change over millennia, like a flower opening in the dark. And long after the merger is complete, the new galaxy will continue to evolve. Its stars will settle into stable orbits, its shape smooth and calm. The chaos will fade into harmony again. The Milky Way and Andromeda will no longer be two. They will be one, a single, enormous presence gliding through the cosmic web, surrounded by the quiet glow of its smaller companions. Even then, the journey will not end. Gravity will keep pulling, drawing Milky and its cluster toward even greater concentrations of mass toward the heart of the Laniakea supercluster, and beyond, toward the mysterious gravitational center we call the Great Attractor. The dance will continue, as it always does, each step slower and grander than the last. So, when you look up tonight and spot Andromeda as a faint mist above the horizon, remember this. You are seeing your galaxy's future partner, the one it has been moving toward for eons. It's a love story, written in gravity, playing out over billions of years. Two great spirals, bound by fate, falling gently together in the slow waltz of time. And when they meet, the light from that union will travel across the cosmos for eternity, a soft glow marking the place where two galaxies became one. Between the grand spirals and bright clusters, between all the galaxies that blaze like islands in the sea of night, there are ghosts. They drift in the spaces. No one notices the wide, dark intervals that lie between galaxies. They are faint, nearly invisible, yet they tell one of the quietest and strangest stories in the universe. Astronomers call them intergalactic stars, suns that wander alone, unbound to any galaxy. Some were born in small galaxies that were later torn apart by larger neighbors. Others were flung out during collisions, caught in the gravitational tides that rip through space when galaxies pass too close. Once cast out, they drift forever through the void, carrying the light of home long after their homes have vanished. To see one of these stars is almost impossible with the naked eye. They are too faint, too scattered. But telescopes, patient, persistent, tireless, have found their traces. The Hubble Space Telescope once captured faint arcs of light between galaxies in the Virgo cluster. Those arcs were not illusions or galaxies in the making. They were rivers of stars, hundreds of thousands of light years long, floating freely in space. Some of them are so old, they have traveled for billions of years without coming close to another galaxy again. Imagine one of them, a single star, not unlike the Sun, surrounded by nothing. No neighboring constellations, no Milky Way stretched across the sky, only a black horizon in every direction. Around it, perhaps a few planets orbit silently, their nights unbroken by any distant light. On one of those worlds, if such a world exists, the concept of sky might not even exist. There would be a sun, but no stars to measure the dark. It's almost heartbreaking, isn't it? The idea of a star alone in an infinite void. But there's beauty there too, a kind of quiet dignity. These are the orphans of the universe, survivors of cosmic upheaval. When galaxies collide, billions of stars remain bound to their new host, but millions more are thrown outward, escaping gravity's grip. Those exiles light the void with faint glimmers, creating halos that stretch far beyond a galaxy's visible edge. The space between galaxies isn't empty. It's full of these ghosts, their light whispering through eternity. In the most massive galaxy clusters, these intergalactic stars form vast glowing clouds called intracluster light. If you could see it with your eyes, it would look like a pale mist weaving between the galaxies, a faint golden fog made of countless lonely suns. That glow is so dim that it took astronomers decades to confirm it was real. For a long time, they thought it might be a trick of their instruments, a reflection or background noise. But as telescopes improved, the truth emerged. The clusters themselves are wrapped in ghost light, the collective shimmer of stars that no longer belong anywhere. Some of those stars die out there, alone. Their supernovae flash briefly, lighting the emptiness like a match in a dark cave. Others collapse quietly into white dwarfs, their heat slowly fading over billions of years. There are even rogue black holes, remnants of dead galaxies wandering among them, invisible but powerful, bending light and time as they move. These are the hidden citizens of the cosmic wilderness. The space between galaxies is also home to something even more mysterious: intergalactic gas. Thin, transparent, and spread across unimaginable distances, this gas is the raw material from which future galaxies might one day form. It's faint, almost undetectable, but when light from distant quasars passes through it, it leaves fingerprints, tiny absorption lines in the spectrum. By studying those marks, astronomers can map where this invisible matter lies, revealing yet another layer of the cosmic web. Some theories suggest that even dark matter gathers here, forming faint bridges that link galaxies across millions of light years. If you could see the universe in dark matter, those spaces would not be black at all. They'd glow with unseen connections, soft filaments stretching endlessly, holding everything together. And though these regions may seem distant, we are closer to them than we realize. At the outermost edge of the Milky Way's halo, stars already begin to thin. Beyond that, perhaps halfway to Andromeda, lies true intergalactic space. If a spacecraft could somehow escape our galaxy's gravity, it would enter that lonely domain, a realm where no one galaxy's light dominates, and the darkness between them hums with the faintest traces of ancient energy. It's strange to think that even there, life could persist. Perhaps not as we know it, but in forms adapted to the endless cold microscopic travelers clinging to comets or drifting on frozen dust. Or maybe, one day, humanity's descendants will cross that distance, guided by faint lights, the intergalactic beacons left behind by stars that refuse to stay bound. Because even out there, in the silent reaches of nothingness, there is still light. There is always light. And in its persistence lies something profoundly human, the refusal to disappear, the desire to shine, even when surrounded by darkness. So as you listen now, Imagine the space between galaxies not as emptiness, but as a slow, endless sea filled with drifting suns. They are not lost. They are explorers. They carry the stories of the galaxies that made them, and though they will never return, their light continues to move forward, crossing millions of years, billions of kilometers, just to be seen. And maybe that's what we are, two small, luminous wanderers, casting our light into the vastness, hoping it will one day reach someone, somewhere, who will look up and see it. Because even between galaxies, even in the loneliest parts of the universe, the story never ends. It simply travels onward, quietly, forever. Numbers are the way the human mind tries to touch the infinite. We measure, we compare, we count, not because the universe demands it, but because we crave to understand our place within it. Yet when it comes to galaxies, numbers are like waves breaking against a shore that has no end. Every statistic about the Milky Way sounds vast, but beside the universe's true giants, it becomes a whisper. Our galaxy is enormous. Yes, about 100,000 light-years across, containing roughly 400 billion stars and weighing nearly 1 trillion solar masses. It takes light itself 100 millennia to cross from one edge to the other. If you traveled at the speed of a jet plane, it would take you more than 100 billion years to make the same trip. These figures sound unreachable, almost godlike, until you compare them to the cosmic titans beyond. Consider IC 1101, the largest known galaxy, sitting over 1 billion light-years away. It stretches across 6 million light-years, 60 times wider than the Milky Way. Inside it are an estimated 100 trillion stars, enough to form 1,000 galaxies like ours, and still leave room for more. The black hole at its center may be 40 billion times the mass of the Sun, a gravity well so immense that entire solar systems could vanish within it. Standing beside IC 1101, our galaxy would look like a speck of dust orbiting a golden mountain. Even IC 1101 is not alone in that category. The Alcyoneus galaxy, discovered more recently, is the largest known radio galaxy, stretching 16 million light-years from end to end when measured by its radio-emitting lobes. Imagine a structure so large that if the Milky Way were placed at one end, its farthest stars wouldn't even reach a fraction of the distance to the other side. It's less a galaxy than a continent of light. And yet, despite their size, these giants glow faintly. They are diffuse, their stars spread thinly across the void. Our Milky Way, dense and spiraled, burns brighter and livelier than many of them. Like a smaller flame that dances faster, it is still forging stars, still birthing light. The big ones, magnificent as they are, have grown old. They've used their fuel. They shine with the quiet dignity of age. Astronomers often speak of luminosity, the measure of how much energy a galaxy emits. The Milky Way's luminosity is equivalent to about 10 billion suns. That's staggering. Yet there are galaxies whose light equals hundreds of billions of suns. The quasar TON 618, technically not a single galaxy but an active galactic nucleus, outshines entire clusters. Its central black hole is so voracious that as matter falls into it, it releases more light than 1,000 Milky Ways combined. In human terms, it's like watching one candle outshine a city. Even more humbling is the scale of distance. The nearest large galaxy, Andromeda, is 2.5 million light-years away, close enough that its light reaches us as a pale blur. The nearest giant elliptical, M87, sits 53 million light-years away. IC 1101, 6 million light-years wide, lies more than 1 billion light-years from Earth. Light traveling at 300,000 kilometers per second has been on the road since before life on Earth began, just to bring us its image. We are always looking into the past, not by seconds or centuries, but by ages older than our species itself. When astronomers calculate the mass of a galaxy, they include not just stars, but dark matter, the unseen weight that surrounds them like a shadow. In the Milky Way, dark matter outweighs visible matter by a factor of 5. For the largest galaxies, the ratio is even higher. That means that even the most titanic systems we've discovered are mostly invisible, their true bulk hidden behind a veil we cannot lift. If all of the Milky Way's stars were replaced by grains of sand, the pile would fill a sphere 30 kilometers wide. Now imagine doing the same for a galaxy like IC 1101. You would need enough sand to bury a planet. These are numbers beyond counting. Quantities that stretch mathematics to its poetic edge, where numbers turn into metaphors for wonder. Still, numbers have a way of comforting us. They give shape to the incomprehensible. When you learn that our galaxy is 100,000 light-years wide, you can picture it, hold it in your mind for a moment, like a glowing disk. When you hear that other galaxies are 10 or 50 times larger, it doesn't make the Milky Way smaller, it makes the universe grander. It tells you that creation does not end with what you can see. And even among those giants, our galaxy holds its own quiet power. It may not be the biggest or brightest, but it is a place of balance, a galaxy still alive, still breathing, still creating. It shelters billions of suns, each with worlds of their own. It has survived collisions, absorbed smaller galaxies, and spun gracefully for over 13 billion years. Its spiral arms still shimmer with star nurseries, while its black hole rests quietly, waiting, patient as time. The giants of the cosmos show us the extremes, the limits of what matter and gravity can build. But the Milky Way shows us something else: harmony. It reminds us that perfection isn't always in scale, but in balance. If the giants are symphonies, the Milky Way is a song one that has been playing for billions of years, soft enough for life to listen. So tonight, as you picture those massive galaxies shining far away, don't think of our galaxy as small. Think of it as home, a masterpiece in miniature, turning quietly amid giants. Because even in a universe measured in impossible numbers, meaning is not found in size, but in the miracle of being able to count at all. And somewhere, beyond the reach of every telescope, the light from the Milky Way joins theirs, a single note, added to the endless cosmic chord that never stops playing. Every galaxy has a heart, though most of the time we cannot see it. The Milky Way is no exception. At its center, 26,000 light-years away from where we float in the Orion Arm, lies something so dense, so powerful, that it shapes the motion of everything around it. It is called Sagittarius A*, a supermassive black hole weighing about 4 million times the mass of the Sunday. We cannot see it directly, but its presence is felt in the way nearby stars move, in the radio waves that flicker from its edge, in the strange, silent pull that defines the center of our home. For centuries, humans had no idea there was anything special at the core of our galaxy. When we looked towards Sagittarius in the night sky, we saw only a bright haze, the combined glow of millions of stars and nebulae crowded together. The center of the Milky Way lies hidden behind thick clouds of interstellar dust, invisible to optical telescopes. Only with radio, infrared, and X-ray observations did we begin to pierce that veil and discover the beating heart within. In the 1,970 seconds, astronomers using radio telescopes noticed a compact source of energy at the center of the galaxy. It was emitting powerful radio waves, far stronger than any ordinary star could produce. They named it Sagittarius A*, the asterisk marking it as extraordinary. Later, using infrared telescopes, scientists began to track the motion of stars near that mysterious point. What they saw defied imagination. Stars were orbiting something unseen, and they were moving incredibly fast. One star, called S2, completes a full orbit every 16 years, traveling at over 25 million kilometers per hour when it swings closest to the center. At that speed, it would circle Earth in less than a minute. Nothing but a massive, compact object could produce such gravity. From those orbits, astronomers calculated the mass of the invisible source, 4 million suns packed into a space no larger than our solar system. There could be only one explanation: a black hole. In 2022, after decades of effort, the Event Horizon Telescope captured an image of Sagittarius A times itself. It wasn't a simple photograph, but a masterpiece of coordination radio telescopes across the world, synchronized to act as one enormous eye the size of Earth. The result was a glowing ring of light surrounding a dark center, the shadow of the black hole. That light is not from the black hole itself, but from gas and dust spiraling into it at nearly the speed of light. As the material falls inward, it heats to millions of degrees, emitting radiation before vanishing into the event horizon, the boundary beyond which nothing, not even light, can escape. Standing near such a place, if standing were possible, would be like looking at the edge of time. Space itself bends, clocks slow, light curves around the darkness and disappears. And yet, for all its strangeness, Sagittarius A times is calm compared to the black holes at the centers of more active galaxies. Some of those feed on torrents of gas, shining as quasars bright enough to outshine trillions of suns. Our own black hole is modest, a sleeper, occasionally stirring, occasionally glowing, but mostly quiet. Around it, stars move in intricate patterns, their orbits tracing invisible ellipses through the crowded central bulge. There are red giants, young blue stars, and clusters so dense they look like glittering smoke. These stars live in one of the harshest environments in the Milky Way, a realm of intense radiation, magnetic fields, and gravity strong enough to tear apart comets and clouds of gas. Yet, even there, new stars are born. In the very shadow of the black hole, life's raw materials continue to churn. It's strange to think that at the heart of something as luminous as a galaxy lies an object of perfect darkness. But that darkness is not absence, it is balance. Without Sagittarius A*, the Milky Way's center would scatter apart. The stars of the bulge would drift away, their orbits unbound. The black hole's gravity provides a silent anchor, holding the galaxy's structure in place, orchestrating the slow rotation that has defined our home for billions of years. Scientists now suspect that nearly every large galaxy in the universe has a black hole at its center. Some are small, like ours. Others are monsters, billions of solar masses deep. And their growth, and the growth of their galaxies, are intertwined. As one feeds, so does the other. In a cosmic sense, the black hole is not the end of the story, but the engine of it. It shapes the galaxy's stars, regulates its gas, and writes its future. If you could travel toward the galactic center, you'd pass through a region thick with stars tens of thousands within a single light year. The night sky there would be radiant, with no darkness between the stars. The light would come from every direction, bathing everything in a perpetual golden dusk. Yet, as you approach Sagittarius A*, the light would dim. You'd see the stars swirl faster, their orbits tightening, until at last the sky would twist and bend, a whirlpool of starlight, circling a silent void. But perhaps what's most beautiful is what this black hole represents. It is the ultimate paradox, something infinitely small, infinitely heavy, invisible, and yet essential. It reminds us that even in the heart of light, darkness has its place not as destruction, but as gravity, as structure, as the quiet center that lets everything else move. And maybe that's true of more than galaxies. Maybe every life too has its center of gravity, the silent core that keeps everything from flying apart. For the Milky Way, that core is Sagittarius A*. For us, it's whatever holds our orbit steady. Memory, love, or the quiet awareness of being part of something vast and beautiful. So as you close your eyes tonight, imagine that you can feel it, the slow heartbeat of our galaxy, pulsing from the center, invisible but constant, a dark sun that never shines, yet holds every star in its gentle, irresistible pull. If you listen closely to the silence of the universe, not with your ears, but with your imagination, you might sense something rhythmic beneath it all. The Milky Way, our luminous home, is not still. It breathes, it turns, it pulses. Its heartbeat is slow, measured in millions of years, but steady. It is the rhythm of gravity and light, of birth and death, of stars rising and fading in endless cycles. We often think of galaxies as static pictures, the glowing spirals captured by telescopes, frozen in time. But that stillness is an illusion. A galaxy is alive, in motion. Every part of the Milky Way moves. Its arms twist like slow whirlpools. Its stars orbit the core in vast ellipses. Its gas clouds drift and collapse to form new suns. Even the invisible halo of dark matter breathes in its own way, expanding and contracting subtly under the cosmic tides that pull on it. The rotation of the Milky Way is its slow, cosmic heartbeat. Our sun and all the stars around it are moving together, circling the galactic center at nearly 828,000 kilometers per hour. Despite that speed, it will take about 230 million years for us to complete a single orbit. Every turn of that grand spiral is one heartbeat, one galactic year. Since the sun's birth, we've made about 20 such revolutions. In that time, entire species have appeared and vanished on Earth. Continents have shifted, mountains have risen and eroded away. Yet, through it all, the Milky Way has kept turning, patient and eternal. As our galaxy rotates, its spiral arms behave like waves rolling through an ocean of stars. They are not fixed structures, but density waves, regions where stars and gas momentarily crowd together, igniting bursts of star formation before moving on. Newborn stars blaze to life in these arms, lighting them with blue brilliance, while older stars trail behind, drifting outward like glowing embers. In this way, the Milky Way renews itself, one pulse at a time, endlessly creating and fading, like lungs inhaling and exhaling starlight. Deep within the galactic disk, clouds of hydrogen gas flow and fold into themselves under the pull of gravity. When they collapse, the pressure inside them rises until nuclear fusion ignites a new star is born. That single act, happening millions of times across the galaxy, is what gives the Milky Way its heartbeat. Each birth sends ripples of energy and radiation outward, stirring the surrounding space. Each death, when a star explodes in a supernova, sends shockwaves back into the interstellar medium, compressing new gas clouds and triggering more births. The galaxy is not a static sculpture. It is a perpetual motion of creation. The center of the Milky Way, too, contributes to this rhythm. Sagittarius A*, the supermassive black hole, flares occasionally small bursts of radiation caused by bits of gas and dust falling into its event horizon. Those flares ripple outward through the surrounding regions, lighting the galactic bulge for brief moments before fading. Scientists call these outbursts the echoes of the Milky Way's heart, reminders that even a seemingly silent core can stir from its sleep. Astronomers have found that our galaxy hums with low-frequency waves, cosmic vibrations that move through its magnetic fields and plasma. These waves can take thousands of years to cross a single spiral arm, shaping the motion of gas and dust. In this sense, the Milky Way really does sing, though its song is too deep for human senses to perceive. If you could translate those frequencies into sound, They might resemble a long, slow tone like the breath of wind through a cathedral too vast to imagine. And beyond sound, there are rhythms of light. Across the galaxy, variable stars pulse, expanding and contracting, brightening and dimming their cycles, acting like the ticking of clocks scattered through space. Some pulse every few days, others over months or years. These stars, called Cepheids, helped astronomers measure the scale of the Milky Way and the distance to other galaxies. They are like the galaxy's heartbeat made visible, their rhythms recorded in light rather than sound. Even our solar system's path through the galaxy follows a wave. As it orbits the center, it rises above and dips below the galactic plane, completing one oscillation every 60 million years. This gentle motion, like a leaf drifting on cosmic tides, may influence the environment of our solar system, brushing us through regions rich in gas or cosmic dust. Some scientists speculate that these oscillations might even coincide with patterns of extinction on Earth, as our planet periodically moves through denser regions of the galactic disk. The heartbeat of the galaxy, it seems, might subtly echo in the rhythm of life itself. Yet for all its motion, the Milky Way feels calm from our perspective. We do not feel the speed of our orbit, nor the gentle undulation of our path. The heartbeat of the galaxy is too slow for human senses, too grand for our brief lifetimes. But if you stretch your imagination far enough, you can picture it, a breathing spiral of light, each pulse taking millions of years, each rotation a chapter in the universe's long story. The heartbeat of the Milky Way connects us to time itself. When you gaze at the night sky, you're seeing light that began its journey thousands, even tens of thousands of years ago. Some of those stars have already died, their light still traveling, a lingering echo in the cosmic rhythm. The galaxy's pulse is written in that light, steady, unhurried, endless. Perhaps that's why we find comfort in looking up. Without knowing it, we're syncing ourselves to that deeper rhythm, slowing our thoughts, matching our breath to the slow turn of the stars. The Milky Way's heartbeat becomes our own. Its calm becomes ours. And so, as the Earth spins and the galaxy drifts through the dark, that hidden rhythm continues, a heartbeat too vast for any single life to hear, but strong enough to carry us all. If you could listen now, truly listen, you might feel it. A soft pulse beneath the silence, the quiet rhythm of forever. Long before the Milky Way became the calm spiral we know today, it was wild, a child of chaos born from fire, dust, and collision. 13.5 billion years ago, when the universe itself was still glowing from the Big Bang, the first galaxies began to take shape. They were nothing like the grand spirals or elegant ellipticals we see now. They were small, rough, and unstable flickering clusters of stars, held together by gravity's first fragile threads. In those early epochs, the universe was a restless sea of hydrogen and helium. Gravity pulled matter into dense knots, forming the first dark matter halos, invisible cocoons, where gas collected and cooled. Within those halos, the first stars ignited, immense and short-lived. They burned hot and fast, fusing hydrogen into heavier elements before exploding as supernovae. Those explosions seeded their surroundings with the carbon, oxygen, and iron that would one day form planets, oceans, and life. The first galaxies were small, some only a few hundred light-years wide, containing a few million stars. They flickered like embers in a vast cosmic night. Over time, they collided and merged, growing larger with every encounter. Each collision mixed gas and dust, triggering new waves of star formation. The Milky Way was built this way piece by piece, from hundreds of smaller systems merging together in a long, slow dance of creation. Imagine it. The early Milky Way forming out of countless fragments, each one a glowing cloud of stars, colliding and merging under the pull of gravity. The night sky then would not have been still. it would have shimmered with movement, the newborn galaxy pulsing with light and shock waves. Even now, astronomers can see traces of those ancient collisions, faint stellar streams that arc through our galaxy's halo, ghostly remnants of long-lost companions devoured by the Milky Way's growth. Some of those early galaxies we can still see, thanks to telescopes like the James Webb Space Telescope, JWST. By capturing light that has traveled for over 13 billion years, we glimpse the universe as it was when galaxies were just forming. These primordial structures are tiny, irregular, and bursting with star formation. Their light is red-shifted, stretched by the expansion of the universe until it glows faintly in the infrared, like the afterglow of a cosmic dawn. In those first billion years, the universe underwent what astronomers call the epoch of reionization. The first galaxies emitted so much ultraviolet light that they stripped electrons from the surrounding hydrogen gas, turning the opaque cosmos into a transparent one. Before that, the universe was like a fog. Afterward, it became clear. Light could finally travel freely, and the cosmic web of galaxies began to shine. Our galaxy's ancestors were among those that transformed the universe from darkness into light. As time passed, the Milky Way's form began to settle. Gas flowed inward, feeding star formation and shaping its spiral disk. The central bulge, dense and spherical, formed early, filled with ancient, metal-poor stars that still burn faintly today. Later, the disk developed, its spiral arms coiling like a seashell around the glowing core. Every part of our galaxy carries a memory of that evolution, each cluster and nebula a page in a story billions of years old. Even now, we can trace that history in the stars themselves. The oldest stars, found in globular clusters orbiting the Milky Way's halo, are nearly as old as the universe, more than 13 billion years. They shine faintly, with little heavy metal content, their light echoing the chemistry of a simpler cosmos. Newer stars, like our Sun, are richer in heavier elements, the product of countless generations of stellar death and rebirth. In their composition, we can read the timeline of creation from the first pure hydrogen fires to the golden metals forged in supernovae. Our galaxy grew not just by merging, but by consuming. Small galaxies, wandering too close, were torn apart by its gravity, their stars scattered into tidal streams. Some still circle us today, like the Sagittarius dwarf galaxy, currently being shredded as it spirals inward. Others have already been absorbed, their remnants now indistinguishable from our own stars. The Milky Way is a survivor of countless cosmic battles and a victor of them all. But even as it built itself, the Milky Way was shaped by its neighbors. The pull of the Andromeda galaxy influenced its motion from the beginning, and the nearby Large Magellanic Cloud continues to tug on our galaxy's outer edges today. We live in a universe where everything is connected, every galaxy bound to others, by invisible strings of gravity, every collision echoing across billions of years. The young universe was more crowded, more energetic, more violent than the one we see now. Galaxies collided more frequently, stars formed faster, and black holes grew at astonishing rates. The night sky of that time would have glowed brighter, dotted with quasars, galaxies whose central black holes blazed like beacons. One of those ancient quasars might have been an early version of our Milky Way's heart, Sagittarius A*, when it fed more actively, shining across the cosmos before settling into its current quiet slumber. And yet, from that chaos, balance emerged. The Milky Way found its rhythm, its spiral symmetry, its calm. It became a place where stars could live long, stable lives, where planets could orbit peacefully, where much later life could evolve and wonder. From the fiery youth of galaxies came the quiet grace of age. When you look up at the stars tonight, you are seeing the descendants of that first age of fire. Every atom of calcium in your bones, every carbon molecule in your breath was once forged in those early suns. You are, quite literally, made of the first galaxies. You are their continuation, the universe learning to see itself billions of years after its beginning. And somewhere in the vast, dark, new galaxies are still being born, small, chaotic, filled with light. The process never ended. The universe is still creating, still growing, still singing the same song it began 13 billion years ago. So when you close your eyes, imagine you can feel that ancient heartbeat still echoing a rhythm that began before the Milky Way had a name, before time had meaning, before light first broke the silence. That rhythm is the story of when galaxies were young, and it still beats within you now. There comes a point, even for astronomers, when the numbers stop making sense. Distances become so immense, time spans so long, and forces so great that words like big or far or old dissolve into poetry. The universe refuses to stay within the lines of reason. It invites us to imagine instead, to drift past the edges of what can be measured and into what can only be felt. That's where we are now, looking beyond imagination at the galaxies so ancient and distant that their light has been traveling toward us since before the Milky Way itself was born. The most powerful telescopes, like the James Webb Space Telescope, JWST, now peer back through cosmic time to just a few 100 million years after the Big Bang. What they reveal is not a tranquil universe, but a storm of creation. Galaxies packed close together, colliding, igniting, glowing in hues of red and gold. These galaxies are small, some only a few thousand light-years across, but incredibly bright. They burn with the energy of stars being born by the millions, consuming their gas in furious bursts. The JWST has shown us galaxies so young that they existed barely 300 million years after the dawn of time. Their light has been stretched by the expansion of the universe redshifted until it reaches us as a faint whisper in the infrared. What we see are not galaxies as they are now, but as they once were, echoes from the universe's first sunrise. And there are surprises everywhere. Some of these early galaxies are far more massive than anyone expected. They shouldn't exist, at least, not according to the models we built. Their stars formed too quickly, their structures too orderly. They challenge what we thought we knew about how the universe evolved. It's as if, in the early dawn, the cosmos skipped ahead, building giants before there should have been enough time. Each discovery forces us to rewrite the story of creation, reminding us that even now, after centuries of study, the universe is not done humbling us. Astronomers use words like redshift, luminosity, and spectral lines to describe these ancient lights. But behind those terms lies something much simpler: awe. To see a galaxy whose light began its journey 13.4 billion years ago is to witness time itself bent into visibility. That faint glow is older than the Earth, older than the Sun, older than almost everything we know. It's not just light, it's memory. It's the universe remembering itself. But even beyond these first galaxies, there are mysteries that stretch imagination further still. We have found cosmic voids, vast regions of near nothingness, some hundreds of millions of light-years wide. In these places, galaxies are rare, and the space between them is nearly empty. If you could stand in one, you would see almost no light at all, just the faintest glow of distant clusters, like campfires on a black horizon. These voids remind us that the universe is not only about abundance, it is also about silence. And then there are the superclusters, those titanic chains of galaxies bound together in webs that span 500 million light-years. The Milky Way is part of one such structure, Laniakea, meaning immense heaven. It's not a single cluster, but a river of galaxies flowing toward a common gravitational center. Beyond Laniakea lies another, and another, and another, in an endless cascade of structure. It's like discovering that our entire galaxy is only one pearl in an infinite string of cosmic necklaces, each one shining faintly in the dark. Even this, though, might not be the limit. Some cosmologists believe that what we call the observable universe, the 93 billion light-years of space we can see, is only a fraction of what exists. Beyond that horizon, there could be countless other galaxies, clusters, and webs stretching on without end. The universe may be infinite, or it may curve back on itself, looping in ways our minds can barely grasp. We may never know, because light from those regions will never reach us. They lie forever beyond the horizon of what can be seen, and so beyond imagination. Yet somehow we can sense them. We can feel that vastness in the same way we sense the ocean when standing on the shore. The waves reach our feet, but we know they come from something larger, something endless. Looking into deep space is like standing at the edge of that cosmic sea, the light washing over us, the silence pulling us outward. We are small, yes, but we are part of it. We are made of the same dust, born from the same explosions, drifting through the same gravity that shaped every star and world that ever existed. When you close your eyes, try to imagine it: the scale, the silence, the endlessness. Imagine galaxies swirling like luminous plankton in the black water of space. Imagine time not as a line, but as an ocean, each wave a billion years, each ripple a heartbeat of creation. In that ocean, our Milky Way is a single spark, our sun a grain of light, our lives a brief shimmer before fading back into the deep. But that shimmer matters, because in the act of looking up, of wondering, of measuring and imagining, we give the universe something it never had before: awareness. Through us, the cosmos learns to see itself. Through our eyes, it witnesses its own beauty. That might be the most extraordinary truth of all, that the universe created beings capable of wonder so that it could finally be known. So when we speak of galaxies beyond imagination, maybe we're not talking about distance or size. Maybe we're talking about that feeling, the quiet, wordless awe that fills you when you realize that you are part of all of this, and all of this is part of you. The light from those ancient galaxies is still traveling, still moving toward us. It hasn't reached its destination yet. In a way, neither have we. We're still learning to understand what it means to exist in a universe that has no edges. And perhaps that's what keeps us reaching farther, not just telescopes, but our hearts stretching beyond imagination, forever trying to see what lies ahead. There's a moment when, staring into the night sky, when the mind quietly asks a question it can't answer: what if we're truly small? Not just physically, not just our planet or our species, but existentially, cosmically, infinitely small in meaning. What if all of this, everything we know, is a whisper in a vast conversation too large for us to ever hear? That thought can be unsettling. We grow up thinking of ourselves as central to history, to creation, to importance. Yet the universe, patient and immense, reminds us otherwise. The Milky Way alone contains 400 billion stars. There are perhaps 200 billion galaxies beyond it. That's more stars than every word ever spoken by human mouths since language began. We are a flicker among oceans of fire, a grain of dust drifting through eternity. But being tiny does not mean being meaningless. It means being rare. Fragility, after all, is what gives things value. Diamonds are precious because they're formed under impossible pressure. Life is precious because it's so improbable. Out of all those galaxies, all those stars, all that emptiness, the universe found a way to look back at itself through human eyes. You are part of that miracle. Let's imagine a perspective. If the Milky Way were the size of a city, the solar system would be a single house, and Earth a speck of dust floating in the sunlight between two rooms. The nearest star, Proxima Centauri, would be another dust mote on the other side of the city. And yet, even from that scale, your breath, your heartbeat, your consciousness, they exist. They matter. They ripple outward, however softly, into the larger whole. Astronomers often speak of the cosmic address, a way of locating ourselves in the universe. It goes like this. You live on Earth, which orbits the Sun, which sits in the Orion Arm, which spirals within the Milky Way, which belongs to the local group, which drifts through the Virgo supercluster, which is part of Laniakea, which flows through the cosmic web of the observable universe. That is your address. And yet, even with all those layers of vastness, your thoughts, your laughter, your small acts of kindness still belong to it all. You are not outside the story. You are the story told in miniature. When we realize our smallness, we often search for meaning. But maybe meaning isn't something that has to be imposed on the universe. Maybe it emerges naturally, like stars forming from gas. Meaning is what happens when awareness meets the infinite, when something tiny begins to feel something infinite. That feeling you get when looking at the stars, that quiet awe, that's meaning itself. It's not separate from science or numbers or scale. It's the emotional translation of existence. There's a paradox here. The smaller we feel, the more infinite we become. A single human mind can hold the image of the entire cosmos. You can sit beneath a small patch of sky and imagine billions of galaxies spinning. You can picture their clusters, their collisions, their deaths, and their rebirths. The universe is so vast it will never fully fit within itself, and yet, somehow, it fits inside your consciousness. That alone makes you larger than you think. Maybe smallness isn't something to fear, but to celebrate. Because what makes us extraordinary is that, despite our scale, we care. We care about beauty, about knowledge, about connection. Stars do not wonder about other stars. Galaxies do not pause to marvel at one another. Only we do. We are the eyes of the universe, the whisper of awareness carried on stardust. The cosmos is vast beyond measure, but without beings like us to see it, it would be silent and unseen, magnificent, yes, but asleep. And maybe that's the secret symmetry of it all. The universe gives us existence, we give it meaning. The stars provide the light, we provide the story. Our smallness is not a weakness. It's the proof that infinity has room for intimacy. Each human life is a galaxy of moments, each thought a star flickering for an instant in the mind's dark sky. Even from a purely physical sense, being small has advantages. Because we are tiny, we can move, adapt, evolve. We can build telescopes that stretch our sight across time. We can send signals and machines to the edges of our solar system. We can turn our insignificance into curiosity, our fragility into empathy. The great cosmic giants, the black holes, the quasars, the galaxies, are powerful but unaware. We, the small ones, are conscious. We know, we wonder, we feel. That may be the universe's greatest achievement. Awareness arising from something so delicate. If you feel small tonight, under the stars, remember this. You are not beneath the universe. You are within it, inseparable from its vastness. The same atoms that make you once burned in ancient suns. The same laws that move galaxies guide your heartbeat. The same light that shines from distant worlds will one day touch your eyes and become memory. The universe is not above you or beyond you. It's inside you, and you inside it. So yes, we are tiny. But the miracle is not that we are small, it's that we are here. Here to notice, here to think, here to feel wonder before drifting back into the stardust that made us. And maybe that's all the meaning we ever need. to know that even a speck of dust can hold infinity, and that the smallest voice can still echo across the stars. Close your eyes. Let the night surround you. You are not lost in the universe. You are the universe, remembering itself quietly, beautifully, one heartbeat at a time. The Milky Way drifts on, turning slowly in its dark ocean, and so do we. From our small world, we look up and see only a fraction of it, a pale river of light arching across the sky. But beyond that glow lies everything. Countless galaxies, stars unborn, light still on its way, and perhaps even realms we will never reach. The story of the universe doesn't end with what we can see. It stretches beyond sight, beyond measure, beyond the horizon of time itself. The phrase, observable universe, sounds comforting, as though it defines a boundary, something finite we can map and understand. In truth, it's only a circle drawn by light. Everything farther away is simply too distant for its light to have reached us since the beginning of time. The observable universe extends roughly 93 billion light-years across. Beyond that, there may be infinite more galaxies, clusters, entire webs of existence, all waiting quietly in the dark. We will never see them, but that doesn't mean they're not there. They are part of the same story, unfolding just out of view. When we think of horizons, we usually picture endings, the place where the sky meets the sea, or where the stars fade into the dawn. But in the universe, a horizon is not an end, it's a promise. It marks the boundary of what can be known for now. With every generation of explorers, that boundary moves a little farther. The same was true for sailors who once feared the edge of the world, for astronomers who thought the Milky Way was the entire cosmos, and for us today, who still wonder what lies beyond the veil of darkness. The horizon doesn't close, it expands, and the expansion itself never stops. The universe is still growing, its fabric stretching faster and faster under the influence of dark energy. Distant galaxies are not just receding, they are accelerating away, carried on the expanding space-time like leaves on a widening stream. Some are already moving faster than light relative to us, which means their glow will never reach our telescopes. Over billions of years, the universe will grow quieter as those galaxies slip beyond our horizon, one by one, like ships vanishing over a cosmic sea. It's a bittersweet thought that the night sky we know today is temporary. One day, far in the future, the Milky Way and Andromeda will have merged into a single glowing galaxy, but the other galaxies will have drifted too far away to see. The sky will grow empty, the stars fewer, the universe colder. Future beings may never know there were once billions of galaxies, unless they find ancient records, faint traces of light preserved in the background radiation. The cosmos is expanding not just in space, but in time, always becoming something new, always letting go of what came before. And yet, even as it stretches outward, something in it remains still. The laws of physics, the harmony of gravity and light, the quiet rhythm of creation, those do not change. They are the heartbeat beneath it all, the steady pulse that continues long after everything visible fades. It's what gives the universe its continuity, its calm. From the smallest particle to the largest cluster, everything moves to that same eternal rhythm. Sometimes, when you think about the endless horizon, it's easy to feel lost in it, to imagine yourself as a flicker that barely matters against the infinite. But look closer. Every horizon you can see, physical or spiritual, exists only because you're here to see it. The act of observation creates a center. Without you, without awareness, the horizon has no meaning. The universe expands in all directions, but consciousness gives it a point from which to expand. The cosmos and the observer are inseparable. One defines the other. Even time, the oldest mystery, is part of this bond. When we gaze at distant galaxies, we are not just looking across space, we're looking back. The light that touches your eyes tonight began its journey millions, even billions of years ago. Every star you see is a message from the past, a memory still burning. The night sky is not a picture of now, it's a mosaic of history. And somehow, within all that ancient light, you exist in this singular moment, a consciousness aware of the infinite past and the endless future. That awareness is rare, it's sacred. Perhaps that's what the horizon truly represents, the boundary between what we know and what we dream. Beyond it lies the unknown, and that is where wonder lives, the urge to explore, to ask, to imagine. That is the universe's most human quality, and maybe its most divine. We have sent machines to the edge of the solar system, photons to the edge of time, and yet the greatest journeys still happen in the mind, in the quiet spaces where thought meets starlight. So tonight, as the galaxy turns and the Earth spins beneath your feet, take one last look at the stars. Each one is a reminder that even in endlessness, there are anchors, points of light that help us find our way. The horizon will always move, always stay just out of reach. But that's the beauty of it. It keeps us moving too. It invites us to keep wondering. The Milky Way will keep turning long after our names are forgotten. The stars will rise and fade. Galaxies will collide and merge. Light will stretch and thin. And yet, the universe will go on, breathing in silence, endless and awake. When you close your eyes now, imagine drifting outward, beyond the stars, beyond the galaxies, past the farthest edge of everything you can picture. There, in that stillness, you'll find not emptiness, but peace, the quiet certainty that the story never truly ends. It only becomes larger, softer, and more beautiful. Because in the end, the universe is not about being large or small, beginning or ending. It is about continuity, the infinite unfolding of wonder. And in that endless horizon, you are both the question and the answer, the observer and the observed, the moment and the eternity. Sleep well, traveler of light. The stars are still turning. The galaxy is still dreaming. And somewhere, the universe is smiling through your eyes.